Good morning, champs. Today, we learn what a complex line integral is and how to compute it. Instead of starting with theory, we go directly into an example. We compute the integral of f of z equals z along a straight line from 0 to 1 plus I. First, we parametrize the curve. We write gamma of t equals t times 1 plus I with t from 0 to 1. This moves us along the straight line. Now we use the key formula. We replace z by gamma of t and dz by gamma prime times dt. So the integral becomes the integral from 0 to 1 of f of gamma of t times gamma prime of t dt. Next, we compute the derivative. Gamma prime is 1 plus I. Now we plug everything into the function. Since f of z equals z, we get f of gamma of t equals t times 1 plus I. Now we multiply. We get t times 1 plus I times 1 plus I. Now we simplify. So the expression becomes 2i times t. Now we integrate. The integral of 2i times t from 0 to 1 is I. So the result is the complex number I. This example shows the full method. We parametrize the curve, compute the derivative, plug everything in, multiply, and integrate. And here is an important question. What happens if we choose a different path? Will we get the same result? We will answer that in the next video.